In this video, we are going to find the inverse of this function f of x equals 2x squared minus 5, where x is greater than or equal to 0. Okay, so again, on this one, we see we have this domain restriction that they have out here off to the side of the function itself. So again, you might wonder, well, what's the story with that? So if we graph out f of x equals 2x squared minus 5, we get this picture right here. It's the parabola, right? And a parabola or a quadratic function, whatever you want to call it, that's definitely not a one-to-one function, right? A lot of horizontal lines will cut the graph in more than one spot. And in the function about inverse, the video about inverse functions, I told you that a function has to be one-to-one to have an inverse. So basically, if they said find the inverse of 2x squared minus 5, well, it doesn't have one, right? So what they have to do is chop this function down, make it on a smaller domain. So the smaller domain that they pick, right, is this domain right here, okay? And now you can see if I only take that right half of the function, well, it is now a one-to-one function if I only consider that piece. So that's the story with this domain restriction. They had to restrict the domain to make a one-to-one function so it would actually have an inverse, okay? Now, unlike the previous examples, this problem this will play a part when we go to solve or calculate what the inverse function is. Okay, all right. So 2x squared minus 5. So everything starts off exactly the same as before. I replace f of x with y. I switch x and y. All right, and then I solve for y. Okay, so if you look at this equation, it is got y squared, so that's a quadratic, right, in y, and I'm solving for y, so that's all I'm really focused on. So you can see I only have the y squared. I don't have a y term. I do have a constant, right? But that's not a big deal. So again, just what I want to do is get the y terms by themselves on one side of the equation, right? And get everything else on the other side. And so first off, I'm going to add and subtract to make it that way. Okay? So add 5 to both sides. I get x plus 5 equals 2y squared. And then to get the y squared by itself, I will divide both sides by 2. So I get x plus 5 over 2 equals y squared. All right, so I have the y squared by itself, right? And so I need to solve for y. I will do that, right, by taking the square root of both sides. Whenever you do that, though, right, remember there are two solutions. Okay, for instance, if I have y squared equals 49, right, if I have that equation, well, then the way you solve that is it's y equals plus or minus the square root of 49, okay? Like that. You have to have that plus or minus there, right, in this type of equation in order to get all of the solutions, right? So that we'll get plus or minus 7. And there are two solutions, right, to this equation. If I plug a 7 in for y, I get 7 squared, that's 49. If I plug a negative 7 in for y, I get negative 7 squared, which is negative 7 times negative 7, which is a positive 49. Okay, so there are two solutions. So you cannot be forgetting, right, this plus or minus over here. Okay, so when I go to solve this equation, right, I solve it exactly the same way as I did that one up there, right? It's going to be y equals, and then plus or minus the square root of x plus 5 over 2. Okay. So I've solved for y, right? But now there is an issue, okay, with that. And that issue is that I have to pick one of these, right? Y equals plus or minus, right? I cannot have both of those, okay? And so the secret to that, right, is to look at this domain restriction right here, right? That domain restriction requires, right, the x's to be positive, okay? All right, and so if you remember how these inverse functions work, and when I plug in a value for x into this function, I will get an output value, a y value, right? And then when I take that and I plug it back in, okay, to the inverse, then the y in the inverse function, the output, which is this one right here, is the number that you plugged into the original, right? And here they say we're only plugging in positive numbers, right, into the original. So what that means is that we choose the positive version in this situation right here, okay? Now, had this domain been x less than or equal to 0, right, we would have chosen the minus version of that as well, okay? So the answer on this one is f of x, or f inverse, is equal to the square root of x plus 5 over 2. I looked through most of the Newton problems and that I could see, and it looked like they always chose the positive one, but that is not always the case, okay? And in some of the explanation in the Newton problems, I didn't really like it because they left off this plus minus here. That will lead to some really bad habits down the road that will negatively impact you in Math 1113 or Math 2253, whatever math you have to take after that. So I feel it's important, right, to always force yourself to put that plus minus in there because it's the correct way to do it, okay? All right, let's take a quick look at the inverse here, and you can see, again, what I'm talking about. So our inverse was, here it was square root of x plus 5 over 2. Let's make it a different color. All right, and you can see that looks right on the money, right? That is exact. Those two graphs are exactly symmetric, right, with the line y equals x right here, okay? And so that's the way it should look. Okay. Now, then, going back, right, if they told us x is greater than or equal to 0, but they could have easily said x is less than or equal to 0, right? Like this. And given us the left half, right, of that parabola, right? And if it was the left half of the parabola, well then we would have picked the minus. You can see without the minus, right, it just it doesn't look right. Those two graphs are not symmetric about the line y equals x, right? If I printed this out and folded it along the blue line, there'd be the black and the green graph would not line up at all, right? So in that case, we would have had to pick the minus. And you can see if we pick the minus one, then that gives us the correct inverse, okay? So in this problem, you have to be careful about that. Like I said, I didn't see anywhere they picked the less than or equal to on the Newton problems, but they could have easily done that, in which case, if you follow their explanation, then, you know, you wouldn't get the correct answer. So just be careful about that. All right, that's it for this one.